Let's take missing at random. Here's the scenario we're working with. So patients come in and the doctors are going to always measure blood pressure if the age is greater than 40. But if the age of the patient is smaller than 40, then the doctor is going to flip a coin. If the coin comes out to heads, they will record blood pressure. If not, they won't record blood pressure. Now, this might happen for several reasons. This might happen because the doctor thinks old people should always get a BP checkup, while for young patients, it only needs to happen sometimes. The important thing to recognize here is that we now have a condition that determines whether or not we're flipping the coin and then whether we're recording the blood pressure. So let's simulate this. Let's say for the first patient, we can see that their age is smaller than 40. So we're going to do a coin flip. So let's say for the first one, the coin flip comes out to be tails. So we will not record the blood pressure. And for the second patient, the age is greater than 55. So there is no coin flip. We just record whatever their blood pressure is. For the third patient, their age is smaller than 40. So again, we will do the coin flip and the coin flip comes out to heads. So we will record this patient's blood pressure and so on and so forth. Now, here's the important thing to recognize is that when the patients are older than 40, we're not doing a coin flip at all. We're always recording the blood pressure. So let's think about what's happening with the frequency of the ages for patients with blood pressure missing and for patients with blood pressure not missing. And so we know that when age is greater than 40, we are never going to not record blood pressure. We'll always have those values. So let's say here we're recording everyone's blood pressure. And so the frequency is 0 for those with blood pressure missing. But now if we're younger than 40, for about half of those, we are not recording blood pressure. And for half of those, we are recording blood pressure. So this is the difference in distribution that we will see between those with blood pressure missing and those with blood pressure not missing as a function of age. And the key takeaway here is that the probability that a blood pressure measurement is missing, it's not constant. It's not the same for everybody. And one example of that is simply that the probability that my blood pressure is missing if the age is smaller than 40 is the flip of a coin, is 0.5, which is very different from the subset of patients for whom age is greater than 40, for which the probability that their blood pressure measurement is missing is 0, because we always record it. And so missing at random is when missingness depends only on the available information. Here the available information is age, and age is entirely determining what the probability of missingness is. And we're going to compare this with another scenario in which the available information won't be all that's being used in order to determine whether something is missing.